Welcome to lecture 2. In the previous lecture, we discussed what is meant by MOS or strength of material. We know that strength of material means that is the ability of a material to resist to failure. The second point one is classification of mechanics, or so that is the classification of mechanics, how the material behaves when a force is acting on the body. Before going with that, we discussed one thing, that is the different states of matter. Alright. What about the behavior of the matter when force acting on the matter? And coming to the next one is, particularly what is meant by difference between the rigid body and deformable body. So particularly in the second year first semester course, we have to describe the behavior of the deformable bodies when force applied on the body by determining the stress, strain and deformation. So today we will discuss the concept of stress and strain, and the second one is the types of the stresses, and then draw the graph between stress and strain for a ductile material. Stress strain diagram. Stress strain diagram. So just today we will discuss concept of stress and strain and types of stresses, and third one is the stress strain diagram to study the behavior of a ductile material by conducting an experiment in a particular one. So let us see the stress and strain. So let us consider a body in a circular shape. So there is no force acting on the body, that is shown in figure number 1. A force system of magnitude F acting axially on the same line tangent in nature. We observed one thing, there is a deformation takes place when a force system of magnitude applied tensorially. So the change in length is denoted as dl. The same force system is applied on the same body in another nature, that is compressive towards the body. Here itself there is a change in length, that is denoted by dl. We can conclude one thing, there is a change in dimensions or change in length whenever it is subjected to a force acting on the body. The change in deformation is called as stress. The change in length, simply the change in length is called as strain. Initially, for example, what is meant by strain? Mathematical, that is the change in length by original length. So what about the original length of the body? L0. What is the change in length? Delta L. The ratio delta L by L0 is called as a strain mathematically. That is the first case. Coming to the stress. So what is the stress? Whenever, let us consider a body, for example, one of its end is fixed for our convenience only. So a force of magnitude P is applied axially. Just P is equal to 10 kilonewton initially. So though there is a 10 kilonewton force acting on a body, there is no measurable amount of the deformation takes place. Just I would like to increase the applied force from 10 to 20. That is, let us consider the second one. So this is the same body. Just whenever the 20 kilonewtons force acting on the body, the change in length is delta L. Alright? One thing is to be remembered. Whenever a force P is acting on a body, this material offers the resistance in opposite direction. This is the resistance offered by the body in opposite direction. This is the applied force. This force, say as P1, P2, P3, P4 be the resistance offered by the body to the deforming force. That is called as a stress. Simply, that is mathematically applied load is P and the cross section area is A. Here mathematically delta L by L naught. So simply, what is meant by strain? That is the deformation when a force applied on the body. What is stress? That is the resistance offered by the body to the deforming force. Mathematically, strain is represented as with epsilon, that is equal to delta L by stress is equal to sigma. Stress is represented by sigma and strain is represented by epsilon. Strain is represented by epsilon. That is the first case. So what is meant by stress and strain? We know that is the concept of stress. The stresses are induced. The stress and strains are induced due to the forces. For example, if you consider the figure number 1 and 2, these two members are structural members or the materials are subjected to the forces of magnitude P axially or directly. Coming to the next case, coming to the second one, this is a force of magnitude P. This is also a force of magnitude P applied on the same structural member in different way. So the stress and strain induced in this particular member accordingly. Coming to the next case, here a torque T is acting on the body in different directions. Again, there is a twisting. The torque is accordingly. The stress and strains are due to the applied torque on it. Coming to the next case, this is a structural member. So for better understanding, this is a structural member. So supported by two supports at the end A and B. Am I right? So subjected to a transverse loads of various magnitudes P1 and P2. The best example is a bridge. The bridge is supported by two columns and the load is acting on the bridge transversely. So definitely we can observe, so there is a bending. Certain amount of the stress and strain induced due to the bending movement. Coming to the last case, whenever the forces acting on a vertical structural member, keep in mind, these two may be horizontal, this must be in a vertical position and a compressive nature. In general, we have the buildings supported with columns. Whenever the force system acting in such a way that this is the force P, alright, axially the structural member must be in vertical position. Then only the structural member is called as column. That must be subjected to a compressive loading system only. There is a buckling. Simply, that is stress and strain induced due to this kind of the system of forces. So based on this classification, so finally they are categorized. So one is due to the direct loading, second one is the shear one, third one is the torque, fourth one is the transverse loads, fifth one is the compressive force system. So based on this force system, the stress and strains are induced and deformation is also takes place. So finally they are categorized. One is axial stresses and strains, second one is non-axial stresses and strains. So these two are comes under the axial stresses categories. The rest of things are comes under the non-axial stress and strain categories. So particularly, let us come to the, whenever let us consider this is a body, alright, a body. A force of magnitude P acting axially towards right, and one more force of magnitude with the same in the opposite direction axially. This is the axis. So this is the axis of the structural member. So the force of magnitude P is acting on a body axially. No doubt about at a certain amount of the load applied on the body deformed. The body deformed. So due to these two forces acting on a body tensile in nature, the tensile stresses are developed and the strains are induced. Simply what happened? There is a change or increase in the, so this is the increase in the length. The virginal length of the structural member or the bar is say as L. There is a change in length say as delta L on left side, and there is a change in length on the right side also. The total change in length simply 2 delta L. The actual length is L. The final length of the beam is simply L is equal to, the initial length is L0 and final length is simply that is equal to L0 plus 2 delta L. Here the 2 delta L is the change in length due to the applied force, that is called as a strain. So then the total length is equal to this one, the initial length is or actual length is L0. What about the strain? Simply that is the strain. Coming to the stress, what about the stress? For example, let us consider any one of the portion either left or right to the section XX. Just consider only right portion of the member. So this is the force P. So definitely certain amount of the force offered by this material, whenever a force P is acting on the body in opposite direction, that is represented by red color, that is the resistance force. Simply this is called as resistance offered by the body to the deforming force P. So that is called as stress. That is, so due to the tensile forces acting on a body, the tensile stress and the strain induced in this member. Let us consider a structural member as shown in animation. These two red colors shows or represents the forces applied axially tensile in nature. At a particular value of the applied force, the member deforms. At a particular value, that is broken or failed. How the structural member reacts to the applied forces P along the axis. This is recording the tensile stress. Coming to the compressive stresses, very simple. So let us say this is a better example or animation gives the better explanation. This is a force applied P. This is also a force P is applied along axially. So for example, this is the body, alright. So subjected to a force of magnitude on either direction on the same line. This is the axis of the structural member. If you observe the two forces of magnitude same and directed towards, right, that type of force system is called as compressive force system. Here itself there is a change in dimension. What happened here? This is the decrease in length. So this is delta L. Again this is also delta L. In both the cases the change in length is represented by only delta L. Here itself there is a resistance offered by the body subjected to a applied force P. Say this is called as R. Here the stress due to the compressive force system is called as compressive stresses. Thus this stress is represented by sigma. We know that that is the R by A, where A is the cross-section area. Here R is equal to P, that is equal to P by A. What about the strain? The strain is change in length. Due to original length, that is equal to, what about the change in length? 2 delta L by L. If it is original length is L. So this animation shows the compressive stress induced and compressive strain induced due to the compressive forces of magnitude P applied axially. Coming to the next case. So next one is the shear stress. So that is the shear stress. Very simple one. This is a body, right? A force of magnitude applied tangentially towards this, and one more force is also applied in this also. That is the one case. Another case, this is a body resting on a horizontal plane, right? A force of magnitude applied tangentially. That is the main difference between the axial and non-axial. So that is the shear stress. So this stress is induced due to the shear force. This animation shows the better, that is, this is a force of magnitude P is applied on the surface, top surface of the structural member. The bottom surface of the structural member is fixed. So due to this applied force, there is a deformation tangentially. That is the shear stress. The corresponding strain is called as shear strain. Coming to the next one, bending. Look at the animation. This is a structural member supported at support 1 and 2. A force of magnitude P is applied at the midspan of the member. The best example is the bridge. So the bridge is supported by the two supports. Number of vehicles are passed or moving on the bridge. Whenever the structural member or the bridge is subjected to a transverse loads, these are the weights of the number of vehicles moving on the bridge. So definitely there is a bending moment caused by the weight or the force of, this is the weight or force of the car 1, say as P1. This is the weight or force of the car or vehicle 2. This is the weight or force of the vehicle 3, and so on. Due to these forces, simply we can observe one thing, there is a bending moment due to the forces. Am I right? So there is a deformation. Look at the figure, there is a deformation. So that deformation is called as a strain. There is a resistance offered by the body to the applied forces or the weights of the moving vehicles, that is called as the bending stress. This animation gives the better explanation regarding to the bending stresses. Coming to the next one is the twisting, where we find the applications, particularly in case of the twisting. Suppose if you want to transmit the power from one place to another place, say just I would like to transmit the power from point A to point B. Particularly we observe the shafts in heavy vehicles like lorries or rice mills. A shaft is rotate on which there are so many belts to transmit the power from one place to another place. If you observe that rotation is caused by the applied torque. Alright? Whenever a torque is acting on that, so certain amount of the stress and strains are induced, that is called as torsional stresses. Coming to the next one, before going to study the behavior of any particular material under different types of the action of forces, or when different kinds of the system of forces acting on a body, we must be familiar what is the normal stress and shear stress. Normal stress means that force acting exactly normal or perpendicular to the cross-sectional area. Here it is not the same. These two animations gives the better explanation. One is regarding the normal and the second one is the shear stresses. Coming to the next case, let us see the mathematically what is the stress and what is the strain. For example, this is a bar or a structural member. A force of magnitude P is applied axially, tensile in nature. Right? So let us consider section A, B. Let us consider section AB. Section AB. Just I would like to consider the force above the AB only. What are the forces acting on a body? Only one force of magnitude P, and that force always tries to deform the body. That deformation is resisted by the forces. These are the forces offered by the structural member. Say that is represented by R. That is represented by R. Definitely, so there is no failure. Failure means it must be P is equal to R. P is equal to R means the body is under equilibrium. It means the net force acting on the member is 0. That is so P is equal to R. Say this is represented in a particular case. What we know that the stress defined as the resistance offered by the body to the deforming forces. Mathematically, stress represented by sigma, that is equal to P by A. So this is the stress mathematically. Then go for the strain. As we know that strain is simply deformation. Whenever the body is subjected to any kind of the system of forces, whether it is axial or the non-axial, particularly for our convenience, let us consider a axial force system, particularly in tensile in nature. The magnitude of the force is P. Alright. Second one is, whenever the two forces of magnitude same in and opposite in direction, we find out one thing. What we found, simply there is a change in length. There is a change in length. The red color portion represents the change in length. So mathematically that is represented as delta L. What is the original length of the structural member? That is the original length of the structural member is L. Here the total elongation is 2 delta L. The original length is L. As for the definition, change in length by original length is the strain. So that is the mathematical definition of the stress and strain. So for our convenience, for better understanding, so what happened so far? What happened? Simply, this is a body. One mathematician observed, or by conducting several experiments on a particular material or various materials, he observed and concluded one thing. So a force of magnitude P is equal to 10 kilonewtons applied initially. He observed one thing. What he observed, there is a deformation takes place. Its deformation is represented by delta L due to the 10 kilonewtons. Then he would like to increase the applied force, again the same member. Then he would like to increase the applied force to a 20 kilonewtons. Then he observed and concluded one thing. What happened? So he find out there is a deformation. Again, some more deformation is place. That is also delta L, for example. So we can conclude one thing. Whenever the body is subjected to 10 kilonewtons, the deformation is proportional to the 10 kilonewtons, that is equal to delta L. If it is increased, its deformation becomes 2 delta L. It means if you increase the force, the deformation or the increase in length is also increases proportionally. One mathematician, Robert Hooke, conducted several experiments on various materials with different cross-sectional areas. Finally concluded one thing: the stress is always directly proportional to the strain. He concluded one thing. After that, the mathematician Thomas Young's introduced one constant. So it is proportionality is replaced by one constant E. One constant E. That is the Young's modulus E. So finally he concluded one thing. So stress is equal constant E into epsilon. What we find out, whenever a body is subjected to any kind of the system of forces on any member, on any different materials, simply they conclude only one thing: the stress is always strain up to certain limit only. It is very, very important. That is up to certain limit. That limit is called as elastic limit. That limit is called as elastic limit. For example, for better understanding, if you increase the load further 20 kilonewtons, what about the total load acting on a particular member? That becomes 40. If you apply the 40 kilonewtons force on the same structural member, on the same material, definitely we observe one thing: the material is failed. It means the applied force is limited. The resistance to the deforming force is also limited. That is the limitation. That's why, so that is the limit, that is the elastic limit. The stress and strain is always proportional up to a certain value. That value is called as elastic limit, or is known as the Young's modulus or modulus of elasticity. For our convenience, let us see one problem. So, what about the problem? A steel bar of a diameter of 20 mm and length of 400 mm is subjected to a tensile force. Tensile force. So, I would like to represent the tensile force system graphically. What about the force? This is the force 10 kilonewtons. Tensile in nature, that is 40 kilonewtons. Right? Next one, the tensile stress. Just what we have to determine: tensile stress and the corresponding strain. We have to calculate the stress and strain. So for that, we know the Young's modulus. We know that the given data is, what about the given? The first one is diameter is 20 mm. The diameter is 20 mm. Diameter D is equal to 20 mm, and the length L is equal to 400 mm. Right? The load T is equal to 40 kilonewtons. Right? The Young's modulus is equal to 200 kilonewton per mm square. This data is sufficient to determine the tensile stress and strain. We know that relation: stress is equal to E into strain, or E is equal to Young's modulus is equal to stress by strain. Again, stress is equal to P by A and strain is equal to delta L by L. What we have to find? Strain means that is the delta sigma of epsilon. This is to be calculated. So this is the